Hello, my dear students. Let me welcome you all to today's session. In this video module, you are going to solve a few questions based on the topic circles. Make sure that you have gone through the concept video that is related to circles, which I have posted earlier, and then start attempting the questions. The best way to learn this topic it's by solving questions on your own. So when the first question, it is presented on the screen, you may pause this video module and then take your time to solve the question and then continue watching the video. And then please check whether you got the right answer or not. Okay. So let's get started. Let me present in front of you the first question. Consider the question here. It's given in the figure O is the center of the circle. It's given angle OAB, it is 65 degrees, and angle OBC, it is 70 degrees. The question is, what is the measure of angle AOC? So, the circle it is given here. We can see that O, it's the center of the circle. It's given in the question that angle OAB, O to A to B. Okay, this angle, it's given to be 65 degrees. Okay, so I'm just marking it over here, 65 degrees. Further, it's given angle OBC, it is 70 degrees. So OBC, O to B, and then B to C. This angle, they have indicated that it is equal to 70 degrees. All right. And you are asked to find the measure of angle AOC, A to O, O to C. Okay, so this angle, I shall indicate it. This angle, that's what they are asking you to find. Okay. Now, it's given that O, it is the center of the circle. Point A, point B, point C, they all are lying along the circumference of the circle. So, can I not consider that OA, it will be equal to OB? It should also be equal to OC because they all corresponds to the radius of the same circle. So, I shall just indicate it OA, OB, OC, they all are equal in length. So, I can thus consider that triangle OAB. I want you to focus on triangle OAB. Can I now consider that the base angle, since OA and OB, they are equal? Can I not consider that this base angle over here, this has to be, if this is 65, this has to be 65. Can I not consider it this way? So this measurement, I shall indicate it. This will also be equal to 65 degrees, right? Okay. Now, it is given that angle OBC, O to B, B to C, it is 70 degrees. We are asked to find the measure of angle AOC, right? So now, what I am going to do further here is, I will consider 65 plus 65. This is equal to 130, right? 65 plus 65, 130. But for triangle OAB, sum of all the internal angles, it should be 180 degrees, which means I can thus see that the measure of angle AOB, it should be equal to 50 degrees. So I shall just mark this here. This will be coming as 50 degrees. Okay. Now you can say 65 plus 65, 130. 130 plus 50, 180 degrees. Okay. In the same way, when I am observing this triangle OBC, look at triangle OBC. Can I not see that the base angle OB and OC, since the sides they are equal, the base angles, it should also be equal. Can I not say that OCB, this will be equal to 70 degrees? So that you can see here 70 plus 70, already it is 140. But look at triangle OBC, sum of all the internal angles, it should be equal to 180 degrees. So, can I not thus conclude that angle BOC, it has to be 40 degrees. So, I shall just mark it here. This has to be 40 degrees, right? Because OB and OC, they are the radius of the same circle. Triangle OBC, when you are considering, I can deal with it as a isosceles triangle. So the base angle will be the same, 70-70 ho gaya, right? So that helps us to find out the measure of AOB 50 degrees, the measure of BOC 40 degrees. You are asked to find the measure of angle AOC, right? What is this angle AOC then? Can I not say that that is equal to this 50 degrees plus this 40 degrees? Because this full angle, when you are going to measure it, it will be 50 plus 40. The total, you can say this will come as 90 degrees. Okay. So that is going to be the answer for my first question here. Okay. Now let's attempt the next question here. The distance between two equal and parallel chords in a circle, it's given to be 24 centimeters. If the radius of the circle, it is 20 centimeter, what is the length of each chord? So please recall one important point what we have discussed in the concepts. Equal chords, okay? Equal chords are equidistant from the center. Okay, from the center of the circle. Okay, this is one point that you have to keep in mind. If the chords, they are equal in length, equal chords, they are equidistant from the center of the circle. The second point that you have to keep in mind is that the perpendicular that is dropped from the center of the circle, okay, the perpendicular dropped from the center of the circle, you know what it does? It will bisect the chord. Okay, so this is another important result that you have to keep in mind while solving this question. So let's get started with the question. I'm now going to consider the circle here. So let this be the circle. Okay. Now, the two chords. I'm going to consider the two chords. Let me call it as chord AB and let me call it as chord CD. Okay. I'm considering that these are the two chords. Okay. And these two chords, AB and CD, they are parallel to each other. And not only that, these two chords, they are of same length because it's given two equal and parallel chords. Like that it is given. Okay. Now, let me consider that the center of the circle. Okay. Let that be O. O, it is the center of the circle. Fine. So the chord AB, I'm considering the chord CD. They are parallel to each other. And also the length of AB and the length of CD, it's also equal. Okay. So now, if I'm going to consider that I'm dropping a perpendicular from O to CD, and also I'm dropping a perpendicular from O to AB, okay, I can thus see that they meet at this point. Let me say P here, okay, it meets our CD at this point P. They meet AB, let me say at this point Q, right? Since we saw that equal chords, they are equidistant from the center, OQ, I can consider that this is equal to x units. OP, it is also x units. Equal chords are equidistant from the center. So OQ and OP, they are x units each. But it is given that the distance between these chords, it's given as 24 centimeters. And it is given that they are parallel chords. Okay, so that helps us to infer that 2x, that is the distance between the two parallel lines, the two parallel chords. The 2x, it is equal to 24 centimeters. And will that not give me x, it is equal to 12 centimeters? Okay, so I got the value for x here as 12 centimeters. So I'm going to just mark that here. Okay, so please observe, I got this value here as 12 centimeters. OQ, it is 12. And OP, it is also 12. Fine. In the question, further it is given the radius of the circle is 20 centimeters. So I'm going to consider the radius now. The radius, I'm going to draw O to B. I can consider O to D. Okay. The radius, it is equal to 20 centimeters. They have given that. Okay. So I shall just mark that here, 20. Now, we can see that the perpendicular drop from the center of the circle to the chord, it is going to bisect the chord. Okay. The perpendicular drop from the center of the circle, to the chord, it will bisect the chord. So this helps us to infer that AQ, it will be equal to BQ. Since they are parallel to the two chords, they are parallel to each other. I can see that CP, it will be equal to DP. And also, I can see that they will all be equal in length. Okay, they all will be. I can just connect them together and I can see that here AQ, it is equal to BQ. It will be equal to CP. It will be equal to DP. Okay, it will come like that. Because we are considering the same circle, two equal chords, they are equidistant from the center. So because of that fact, AQ, QB, CP, PD, they all will be equal in measurement, right? So let us try to focus on, say, finding the measurement of our PD, okay, or DP. So I do see a right angle triangle here. I can see that DP square plus 12 square, that is equal to 20 square. DP square, I can say that is equal to 20 square minus 12 square. And how much this value will come? DP square, I can see that 20 square, it is equal to 400. 12 square, it is 144. So DP square, you can say 400 minus 144, that is 256. So DP, it will be square root of 256. DP, I will get it as 16. So DP, it is equal to 16. So DP is 16. CP will be 16. AQ will be 16. BQ also will be 16. So what is the length of each chord? I can say my final answer, the length of each chord, it will be 16 plus 16. That will be 32 centimeters. So for this question, 32 will be the answer. Okay. Now, let's go to the next question. In the figure, it's given ABCD. It is a cyclic quadrilateral. It's given AD and BC, they are produced to meet at E. It's given AD is equal to BC and angle ABC, it is equal to 70 degrees. You are asked to find the measure of angle AEB. Okay, so let me present all these details in this diagram. It's given that AD is equal to BC. So this length AD and this length BC, AD and BC, I can see that they are equal in length. Okay, AD and BC, AD is equal to BC. It is given in the question that angle ABC, A to B, B to C, this angle ABC, it is given that it is equal to 70 degrees. Okay, now you are asked to find the measurement of AEB. So A to E to B, this measurement, how much it is? That is what in the question it is asked. Okay, so let's consider that ABCD, it is given to be a cyclic quadrilateral. So for a cyclic quadrilateral, external angle, it is equal to the remote interior angle. We have a result that way. I can use that and then say that this external angle here, it will be equal to 70 degrees. I can use it that way. Or I can even consider in a cyclic quadrilateral, opposite angles are supplementary, right? So angle B, if it is 70 degree, angle D, it has to be 110 degrees because opposite angles, they are supplementary. They add up to 180. So if this is 70, 70 plus 110, it is giving us 180, right? So this has to be 110. Now, since ADE, it is a straight line, can I not consider that this value, it has to be 70 degrees? You can find the answer that way also. You got it? Now, please note here, one thing that you have to observe is that since AD and BC, they are equal, it is given in the question. Considering the similarity aspect, okay, this is 70 degree. This also will be coming as 70 degrees. And by symmetry, I am saying, okay, because it's the same. Okay, you are drawing from E, you are drawing EAD. From E, you are drawing ECB. And it is given that DA and CB, they are equal. So that helps us to infer that the same measurement, this will also be equal to 70 degrees. Okay, so I can see that here because the reason is very simple. In this case, the symmetry aspect comes into picture. EA and EB, they will be equal in length. Okay, because AD and BC, they are given to be equal. From the same point, AD and EC you are drawing. So by that aspect, I can infer that EA and EB, they will be equal. You got it? So that helps us to say that if this is 70 degree, this also will be 70 degree. In the same manner, this also will be, 70 degrees. It will come like that only. Okay. And then I can see that here it is 70 plus 70, 140. Now it is easy for you to find the measure of angle DEC, otherwise angle AEB, whichever. You can say 70 plus 70, it is equal to 140. This angle, it has to be 40 degrees. Okay, so the measure of angle AEB, that's what you are asked to find. You can thus conclude that it will be equal to 40 degrees. Okay, so that's for the third question. Now let's go to the next one, the fourth one. In the question, it is given in the figure PQ. You see PQ? PQ is a tangent and PST, P to S, S to T, it is a secant. If O is the center of the circle, so O is the center of the circle, so you can see that SOT, I can consider it as the diameter of this circle. Okay, SOT will be the diameter of the circle, just for your info. And it is given that PQ, we have P to Q, PQ, it is 8 root 3 centimeters. And it is given angle OPQ, O to P, P to Q. OPQ, yeah, O to P, P to Q, OPQ. This is given to be 30 degrees. So I'm considering this as 30 degrees. Okay. Now further, what is given? What is the length of the radius? Also find the length of PS. That is the question. Okay. So for answering this question, I'll just draw this picture in a slightly enlarged manner. Okay, and then I shall explain. So take a look at this picture. Okay, here we go. So whatever inputs that I could get from the question, I have just converted it. Now, PQ is given to be the tangent, right? And it is given that PST, it is the secant. So Q, it is the point of tangency. Don't you agree with me? This Q, I call it as the point of tangency. So what about our OQ? OQ can be considered as the radius of the circle, correct? No? And the radius, it will be making 90 degree with the tangent and radius at the point of tangency. Okay, they make 90 degrees to each other. They cut at 90 degrees. Yes or no? So I shall just indicate that this has to be 90 degrees at the point of tangency. So you see that this is 30. You see that this is 90. So it is definite that this has to be 60 degrees. Okay. So this measurement, please note, it has to be 60 degrees. Okay. Now we can consider that here PQ, it's given to be 8 root 3. Okay. Now recall, you can even go by trigonometric ratio or the method what I have taught you. Whatever comes opposite to 30, that value into root 3 will come opposite to 60. So that helps me to quickly arrive at the factor that OQ, this has to be 8 units. Because opposite to 30, if it is 8, opposite to 60, it has to be 8 root 3. Okay, that way you can do, or else you can take tan 30. Okay, if you're not comfortable with what I just mentioned, you can just go for tan 30. Tan 30, it is equal to 1 by root 3. What is tan 30? Tan 30, it is nothing but OQ, opposite side by hypotenuse, that is PQ. Okay, so that helps us to see that here PQ, it is given to be 8 root 3, right? So I can say 1 by root 3, it is equal to OQ divided by 8 root 3. So that root 3 cancels off. I can see that OQ, it is equal to 8. That way also I can arrive at it. But if you remember the result, what I just told you, whatever comes opposite to 30, that value into root 3 will come opposite to 60. Whatever comes opposite to 30, double of that will it will come opposite to 90. So I can thus infer that our OP, I repeat, our OP, this has to be double of 8, that is equal to 16. But I know that OS is the radius from O to this point S. This OS is again the radius, and thus I can see that OS has to be 8 units. And thus I can infer that our SP, it also will be 8 units then. PS, SP, it will also be 8 units then. Okay, so the two questions that were asked, what is the measurement of the radius? I can answer that question now. The radius, it will be equal to 8. It's given in centimeters, so 8 centimeters. And also they are asking you to find the measurement of that PS. I can see PS, it will be also equal to 8 centimeters. Okay, in this manner, we have answered the two questions that is asked. Okay, so let's consider the next question here. Take a look at this question. Here, we can see in the following figure, ABC and BCD are two triangles. So where are they? ABC, and you can consider BCD. BCD, ABC and BCD, they are two triangles. They are inscribed inside the circle. If angle BAC is 30 degrees, B to A to C, they say that this is 30 degrees, and angle ACD, A to C, C to D, yeah, that is 80 degrees. You are asked to find the measure of angle AEB, A to E, E to B. Okay, they are asking you to find what is the measurement of this angle. How much is this inclination? You are asked to find this. Okay. Now, I want you to focus very carefully here. Don't you see that this is one part of the circumference BC? Focus here, B to C. Just focus here. Okay, so angle within that BC, You can see that there are two here. One is ABAC. You see that is 30 degree. In the same manner, within this BC, the circumference part, the portion of the circumference part BC, there we have this BDC. Don't you see that? So BAC, since it is 30 degrees, can I not look at this carefully? BAC, since it is 30 degrees, can I not infer that this BDC, it should also be equal to 30 degrees? Okay? Because angle within that same BC, where these points, as they are lying along the circumference of the circle, I can say if this is 30 degrees, this also will be 30 degrees, I can put it. So 80 plus 30, it is 110 degrees it comes. 80 plus 30. If that value, it is 110 degrees, can I not get the measurement of this angle? How much it will be? This has to be 70 degrees. Because sum of all the internal angles of a triangle, it is 180 degrees. So 80 plus 30, 110 ho gaya, plus 70. I have to put here 70 degrees. Okay, now use the vertical opposite angle concept. I can see that angle AEB, this also has to be 70 degrees. It comes like that only. So they are asking you to find what is the measure of angle AEB. I can say angle AEB, it has to be 70 degrees, right? So I got the answer here. I would also mention another point here. Within the same segment, okay, you can say, let us consider the curve here A to D. Okay, please observe A to D. I'm considering. This is just an add-on I am telling you. Okay. A, you can just observe here, ACD, this value, you can say ACD, it is 80 degrees. In the same manner, within this AD itself, we have got ABD. So this also should be 80 degrees. Don't you see that? Just an add-on. Okay, I just thought I shall present it here. Okay, so that is 80. Fine. So please make a note of the same. Now let's move on to the next. So here for this question, the main thing what I asked you was what is the measure of angle AEB? That we have already answered. Okay, A to E, E to B, 70 degrees it comes. And that is the answer, the final answer for this question. Make a note of it. Okay, thus we have completed this question here. Let's go to the next one. In the figure, O is the center of the circle. It is given that AD and AB, they are equal in measurement. They are asking you to find the measurement of angle AOD. Okay, so what I'm going to do here is, again, I shall get an enlarged image here for you. So let me just present it in a enlarged manner. Yeah, here we go. So what I am first going to do here is, I'm going to do a small construction work here. Okay. So I'm going to join this D and B. I'm just going to join them. In the question, it is given AD is equal to AB, right? It's given AD and AB, they are equal. So the construction, I'm putting it like this. Okay. So please observe AD and AB, they are equal, right? So can I not view triangle ADB? Okay, look at triangle ADB. Triangle ADB. View that triangle. Can I not consider it as an isosceles triangle? If that is the case, can I not say that this has to be 70 degrees? This full angle I am saying, okay, that has to be 70 degrees. And this also, need to be 70 degrees. If you're observing 70 plus 70, 140 plus 40, that is coming as 180 degrees. I got that value as 70 degrees, right? Now, when I am observing further, okay, they are asking us to find the measure of angle AOD. Okay, A to O, O to D. So, just imagine if I am going to construct O to A, where O it is the center of the circle, it is given. Okay, I want you to focus on this AD. I use a different color. Just focus on this curve that is AD, like what you see here. Okay, so A is along the circumference, D is along the circumference, B is also lying along the circumference. Got it? And you can see that O, it is the center of the circle. Now recall this AD, the curve what you see, you have AOD here and you have got ABB as you can see. Now, can I not consider that if this angle is theta, angle AOD, the concept we have learned, this angle, it has to be double of 70. It has to be 140 degrees, right? So I can consider this angle here. That is what it is asked here, angle AOD. Please note, angle AOD, it has to be double of 70. That is 140 degrees. And that is the answer for our question here. Okay. And again, a small add-on I shall give you. I know that I have just found out that this measurement, it is equal to double of 70, that is 140 degrees. Cool. Now, please note, OA and OD, they are equal in measurement. Why? Because that's the radius of the same circle. Okay. So, OA and OD, I can consider that they are equal in measurement. So can you not consider, I want you to focus on triangle AOD only. Just look at a small triangle AOD only. Don't you see that it is an isosceles triangle, right? AOD, it's an isosceles triangle because OA and OD, they are equal. Got it? Which means the base angle, that is OAD and ODA, they should be equal in measurement because it's an isosceles triangle. This is already 140, right? So can I not consider that this measurement has to be 20 and this measurement has to be 20. So that 20 plus 20, 40 plus 140, it is coming as 180 degrees in that manner. 140 plus 20 plus 20. I can see that is coming as 180 degrees. So this is 20, this is 20. Got it? And also please note here, I can consider that this is 20. The full measurement is given to be 40. I can thus see that here, the measurement of angle OAB, it will be equal to 40 degrees. Sorry, it will be equal to the remaining 20 degrees it will come. Please note, OAB, it will be 20 degrees. So that 20 plus 20, 40 degrees it is coming. Got it? Now, in the same manner, this total, it is 70 degrees. Already I saw this is 20 degrees. So that helps me to find out angle ODB. Observe ODB. I can see that measurement, it will come as 50. I can consider that will be coming as 50. So that 50 plus 20, that is coming as 70. Please note, I cannot insist that this is 40, this should be 40. Okay, this is 40 and this will also become 40, when only when AB and BD, they are equal. But please note in the question, it is given AD and AB are equal. That's what they have told you. So the base angle 70 and 70, they are equal here. And you can say that this is 40. So all these measurements, I have marked here. That is just an add-on for you, for your extra learning. The question it is asked, what is the measurement of angle AOD? I can say that is 140 degrees and that is the final answer for our question. We have already arrived at the same, but just for your information. Okay. Now let's consider the next question here. Here in the question, we can see that in the figure PAQ, it is given to be a tangent to the circle with center O. Okay, so the circle has got the center that is O. Okay, please make a note of this. And now we can see that PAQ, it is a tangent to the circle with center O. The measure of angle PAC, it is 70 degrees. So P to A to C. This measurement, it is given that it is equal to 70 degrees. Okay. You are asked to find the measure of angle AOC. So let me do a small construction here. A to O and O to C. What is the measurement of this? Very easy. Refer the concept that is related to alternate segment theorem that I have explained. Okay. As per alternate segment theorem, I know that the measurement of angle PAC, it is given that it is 70 degrees, and that will be equal to the measure of angle CBA. Okay, refer that diagram, what I have explained, using which I have explained alternate segment theorem. If this is 70 degree, I can say that this also will be equal to 70 degrees. Okay. For your quick reference, I shall take that diagram for you for your understanding. Okay, for your quick reference. Okay, I need to take the concept video. Okay, right now it's slightly difficult for me to pull this. Okay, so I will just ask you to refer that alternate segment theorem concept. Okay, so here we go. I can see that this angle, if it is equal to 70 degree, this angle, the same will be coming over here, 70 degrees. Now, once that part is over, please note, we are dealing with the curve here. That curve that I am considering is C2. Just observe. C, it comes like this, C to A. This is the curve we are talking about. So CBA, if it is 70 degree, COA, this has to be double of 70, that is 140. Okay, so this measurement, we can consider it will be 140 degrees. They are asking you to find what is the measure of angle AOC, COA. Okay, therefore, I can see angle AOC, it will be coming as 140 degrees. Okay, so if you know the alternate segment theorem correctly, you can quickly say this is 70, that 70 will switch over here 70, and then angle, the small one, it is 70, with the central one, it will be double of 70, 140. It's just a 40-50 seconds question. Okay, you can finish it in that much time. Now, let's consider the next question. Here we go. This is the final question that we are considering in this lot. Let's see. In the figure ABC, it is an equilateral triangle. So, where is ABC? A is here, B is here, C is here. Okay, I can see that ABC, it's an equilateral triangle. And AX is a tangent. So, you are considering AX to be the tangent. What are the measures of angle CAX and angle ACD? So, it is given AD is equal to DC. So, what I will do is I will convert everything that is given here. I will write down ABC is an equilateral triangle. So, I can see that this is 60 degrees. I can see that this is 60 degrees. And I can see that this also will be 60 degrees. Fine. AX is a tangent. Okay. So, I will consider that AX is a tangent there. Let it be A is the point of tangency. Okay. Then AD is given to be equal to DC. So A to D, it is equal to DC. That is C to D. Okay. They are equal. Fine. Now please observe. If this, we can consider that this A, B, C, D, all the 4 points are lying. They are concyclic, I will say. The vertex A, vertex B, vertex C, vertex D. They are concyclic. Can I not consider that ABCD, it is a cyclic quadrilateral? Okay, as ABCD, it is a cyclic quadrilateral. Opposite angles are supplementary. So can I not see that this measurement, it has to be 120 degrees, right? It has to be 120. 120 plus 60 is 180. Got it? And in the question, it is further given that our CD and our DA, they are equal. These two sides are equal. So since this is 60 degrees, can I not consider that this has to be 30 degrees and this has to be 30 degrees? Yes or no? So that you can say 120 plus 60, it is equal to 180. That 60, I'm dividing it equally, 30, 30. Because this triangle DCA, look at this DCA, it is isosceles. So the base angles are equal, right? So now I got this value here as 30. So totally, I can consider that BCD, it is 60 plus 30, 90. BAD, 60 plus 30, 90. I got it. Okay, so they cut at 90 degrees. Fine. Now the next question that I have to understand is using that alternate segment theorem, as AX goes in this manner, this measurement, it is 120 degrees. Observe CDA, it is 120 degrees. Can I not consider that here, this measurement C to this point over here, this angle, full angle that you are considering, can I not consider that that has to be the same 120 degrees because you are considering this triangle, okay, and you are considering that it is going this way, it's a tangent. So this 120 can be switched to here. So please note this full measurement, that has to be 120 degrees. But already I have marked a 60 degree over there. So the remaining, I can now comfortably mark this has to be 60 degrees. Please note in this scenario, when I am considering, you can see that over here, it is 60 plus 60, 120. That 120 is what it is getting, switching to this 120 here. Alternate segment theorem concept. Okay. Now, the question is, what is CAX? That is the question. We can easily find it out. Okay, just observe. This is 60, this is 60, 60 plus 60, 120. 120 plus 30, it is 150. So that helps me to find out this has to be 30 degrees. Got it? So that it adds up to give you 180 degrees. So I shall mark it here. This measurement will come here as 30 degrees. Okay. So please observe, it's a straight line. 60 plus 60, 120. 120 plus 30, 150 plus 30. It is coming here as 180 degrees. Okay. So what is the measure of angle CAX? C to A to X. I can see that angle CAX, this has to be 30 plus 30. That is coming here as 60 degrees. In the same manner, let us find out what is the measure of angle ACD. What is ACD? It is A to C. Okay, A is here. Okay, A to C and C to D. Please observe A to C and C to D. This angle, that's what they were asking you. I can say that measurement, it is coming as 30 degrees. Okay, so here the CAX, the full thing, you can see it is coming as 60 degrees. And A to C, C to D, ACD, I can say it is coming here as 30 degrees. Okay, so that brings conclusion to this question as well. So with this question, we are completing our first level of discussion based on our concepts and problems related to circles. I hope that you have followed all these explanations clearly. And any doubts you have, feel free to get back to me. Okay, thank you. See you soon in another video with another topic. Take care.